this computer. We are going on the 4th version of our keylogger. High input with the latest version of Kali. They updated our Pi input to the 1.81, which does work. So PY input works in the latest valid version of Kali. Yay! So we are looking at some threading. Threading is two different things. A program is a process. In Python, we can run multiple programs, but it's hard to get them to communicate with each other. So if we have a reporting program and we have our input program that's capturing the keystrokes, if we do two separate programs, well, that's not going to work because we can't communicate very well. We're going to use one process, which is a program, and multiple threads. How many programs do you use every day that have multiple threads there, Andy?
Probably a lot of them.
Except for the stuff that we create, pretty much everything, I'm thinking. Everything has multiple processes. Like Google Chrome is am I saying that wrong? Yeah, process. It's a program. Underneath Google Chrome, we have like 13 threads that we can see. That doesn't mean there aren't more running around doing things. So we have things that can work simultaneously. However, the question is it really simultaneous? We have 12 logical processors, right? Because we have 6 physical cores, 12 logical processors, which means theoretically, because there's 2 APUs on each logical core, there should be. So we could do 24 things simultaneously. So how in the world, Andy, Jess, and Sean, do we manage to do all of these things that are more than 24? How do we manage to do all that?
Threading.
Threading, yes, but how does threading work at the hardware level, at the OS level? Sorry.
Yeah.
The OS is the person that runs it. There's a couple terms for it. We can't do more than 24 things at a time, really. And the operating system takes care of scheduling.
I figure it's mostly like the stack where certain things happen first and the next.
And there's priorities, and the operating system says, oh, we need 0.5 milliseconds for Chrome, then we need this, and then we need this. So it rotates amongst all of this. It's time slicing, time sharing. Time sharing like this has been around since like the earliest first mainframe computers. And then Windows decided they weren't going to do that anymore. Linux has always been multiple people running along. So we're going to use a thread library. We're going to have, I think, 4 different threads before we're done. Inside the same program, our threads can communicate with each other and do things. So we're good there. Threading is built in. So we just have to import it. We're importing sleep. We'll take a look at why we're importing sleep. So we have our, I should get out the code. Let me get out the code. I think I was going to get out the code and then I got distracted by our hand, our new robot arm, robot arm controller. Sensory something is what it's called on Amazon. Okay, so now we're looking at number 4. There we are. So, when we create our class, automatically the init function runs. We're creating a blank log. We are going to use a flag as one term for this, or a Boolean. A flag means either the flag is up or it's down. It's like you're flagging somebody down at a raceway. But a flag is one of the terms that we use. So is the reporting thread running or isn't it running? We're going to start our background process on a separate thread. So I thought, well, it's a separate thread, so let's make it its own little method. Well, to start something in a separate thread, it does need to be its own method or function. So all this does is start the thread. That's it. So this adheres to the principle of single purpose or whatever it's called. Single purpose, meaning that's all this does.
Yeah.
Oh, what is that? Oh, there's like a whole acronym, and this is like the first one. Anyway, I can't remember it.
Single purpose, I think this is the name, solid.
Solid, yeah, single purpose. That's all this does is start the thread. It doesn't do anything else. So it starts the thread. With a thread, you have to have either a method or a function that's a target. That creates from this class, right? Class, a report thread. We say the daemon is running. Right? Thread, daemon. What's a daemon?
In the background.
It's a background service.
And what is our report doing? Where is the function report?
And then
Ah,
after we say-
it's just sleeping. Oh, okay.
Okay. So we say that daemon is true, which means when we exit the program, it shuts down. We don't have to, if something goes wrong and it goes berserk, it's a daemon thread, so it shuts down like a service. Then we have to start the thread. Well, Mike asks, what is the report function doing? It is running all the time. So our self-running, remember that guy up here? Yep, it's true. So while self-running is true, we keep printing the log to the console, clearing the log. We're just going to do it for 5 seconds before the next report. The reason we're putting in sleep is eventually we're going to email this log to us, and we don't want it emailing like every millisecond. We want to have a time span while this is running. And normally, sleep, if you put it in a procedural program, what does it do to the program when we only have one thread going on? What does sleep do?
It
Blocks all the process.
It blocks, yeah, it's called a blocking call. Means nothing else can happen, but this is its own little thread. So if this thing waits for 5 seconds, does that affect the rest of our program? Not a bit. So there's our report starting. Okay, good. We got that part going on. We have one thread. Programs always have one main thread that runs the program, always. Now we have two. We have the main program thread. We have our self-report thread. The keyboard listener has a built-in threading function. So now we have three. So we create a keyboard listener. It's going to process the key press, which means it's going down here. Part of this class is that if we pass in a key to the function, it automatically adds that key to the log, which I think I talked about that before. Anyway, with keyboard listener, so this is a keyboard listener, we're starting the keyboard listener object thread. So now we have three things going on simultaneously. Pretty cool. We're going to have, I think, one more when we start doing email. And it works. Of course, now you have to persuade somebody to run it on their computer and pay no attention to it. Oh. Yep, so yeah,
Actually,
75
Bill,
seconds.
I built this code last night and was multitasking, so I went and